Question 42. The diagram below represents a 2 kilogram toy that's moving at a constant speed of 3 meters per second, counterclockwise in a circular path, which has a radius of 2 meters. At the instant shown in the diagram, the centripetal force is going to be what? Well, remember, if we're moving in a circle, the centripetal force is always pointed to the center of the circle. At this particular location, please notice the centripetal force, while it's pointing to the center, can be described as pointing to the west. So 3 is out and choice 1 is out, which means we're down to a 50-50. Now we have to calculate the centripetal force. I think we should go to our reference table. Here on our reference table, we're talking about circular motion, so I'm going to have to use centripetal force as mass times my centripetal acceleration. And also remember, centripetal acceleration is v squared over r. Looking at what they give me the mass of the toy, they give me the speed of the toy, and they give me the radius. So if I just look at FC is m times AC, you'll notice there's a problem. I have my mass, which is 2 kilograms, but I don't have AC. So what I have to do is just simply rewrite this in terms of AC, which is v squared divided by r. There we go. Now I can plug in my numbers. M is 2 kilograms. My V is going to be 3 meters per second. Don't forget to square it. And my R ends up being 2 meters, which makes your centripetal force choice number 4. Question number 43. In question 43, we're looking at an electric circuit, and it wants to know which electric circuit would read a voltmeter of 10 volts. So taking a look here, circuit number 1, this is a parallel circuit. And how about we refresh our circuit equations by heading to the reference table. Looking here at our reference table under circuits, you'll notice that a parallel circuit, the voltages are equivalent to each other. So in a parallel circuit, the voltage is the same across each and every branch. So heading back to the question here, we can eliminate number 1 as a choice because number 1 says that each branch would have 20 volts. I want a reading of 10 volts, so that is not correct. 2, 3, and 4 are all series circuits. So going back to my table here, at series circuits, notice the voltages add up to give you your total. So I need to find voltages that will add up to give me 10. Well, in choice number 2, my total voltage is 20. So if I was to add up number 1 and number 2 voltage together, it would equal 20. I don't want 20, I want 10. So this is out. In choice 3, you'll notice my total voltage here is 10. Well, if I want a reading of 10 volts, there's no way this one can be 10 volts because then there's no voltage left over for the second resistor. So that doesn't make sense. Choice 4, however, if we take a look at the equation, our total voltage is equal to V1 plus V2. Notice these two resistors are the same, which means they'll eat up the same voltage. I think it's safe to say 5 plus 5 is equal to 10. 4 is your choice. Question 44. The lambda baryon has a quark composition of UDS. What particle has the same electric charge as the lambda baryon? Well, I think we got to go to the reference table and take a look at what UDS actually means. So here we're talking about a lambda baryon, which is made up of 3 quarks. And those quarks, it tells us, is a U, which is an up quark with a charge of 2/3, a D, which is a down quark of a negative 1/3, and an S, which is a strange quark of a negative 1/3. So writing these down, we're going to have 2/3 minus 1/3 minus 1/3, which is equal to 0. Since that's equal to 0, what has a charge of 0? A neutron, because they're neutral. Question 45, how many kilograms of matter? How many kilograms of matter would have to be converted into energy to produce 24 megajoules of energy? Any conversion of matter goes to the famous equation of E equals mc squared. Einstein's famous formula converting energy to matter or matter into energy. So using E is equal to mc squared. I don't know about you, but that just gives me a chill that I'm using Einstein's famous formula. I have 24 megajoules. That's the amount of energy. So this is going to be 24 times 10 to the 6 joules. Why 6? Because I'm talking about mega. And if we go to our prefixes of 10 on our reference table, we'll see that mega is 10 to the 6th. Mass is what I'm searching for, and c is always the speed of light of 3 times 10 to the 8 meters per second. Don't forget to square it. And when you solve for your mass, you're going to end up with a mass of 2.67 times 10 to the negative 10th kilograms. Question 46. A red photon in the bright line spectrum of hydrogen gas. We're talking about hydrogen gas has an energy of 3.02 times 10 to the negative 19 joules. What energy level transition does an electron and a hydrogen atom have to undergo to produce this photon? Well, if we head on over to our reference tables and take a look at the hydrogen atom, the first thing that you'll notice is that all the energies are in electron volts. The problem didn't give us electron volts, it gave us joules. So to figure this out, we first have to convert joules into electron volts. Let's set this up. 3.02 times 10 to the negative 19 joules. 1 electron volt is equal to 1.6 times 10 to the negative 19 joules, right there on your reference table. This yields an energy in electron volts of 1.89 eV. Now what we have to do is we have to use E is equal to EI minus EF. This energy of a photon is equal to the difference between those energy levels. And we just check each transition to find one that gives us 1.89. So let's do it. Let's go from 3 to 2. So if I go from n equals 3 to n equals 2, this is going to be negative 1.51 minus a minus 3.4. And these are all in electron volts. And this will equal the energy of a photon. In this transition, I end up with, well, by golly, 1.89 electron volts. Hey, number 1 is our choice. We're going to stop there. Click ahead to page 10 or feel great and redo 7 and 8. Either way, let's get it.